changer, which is the need of the hour, because everything what we have has got two sides of it. There are good things and bad things. Plastics have been a very useful thing for so many years, but now it also got its negative side of it, and a lot of work is being done. So that is what Anthony Harrison and Jacob Harrison from Australia, from the 12-8 technology, will walk you through about this breakthrough technology and introduce how plastics is no more a plastic and it's a game changer, and it will touch main points. And then we will have a question answer session towards the end, 10-15 minutes before. So initially you are muted, then I will unmute you and you can ask the questions, or you can also type it into the chat box. And then later on we can have one-to-one meetings to go deep into technology, send you more technical papers, white papers, etc. So over to you, Anthony and Jacob. You can now start. Thank you.
Thank you, Sandeep. Thank you to the team in India. We are thrilled to be able to share this webinar with you today. We're very excited by our technology that we represent and see it really as a game changer as to the problem that we all know and face, as Sandeep correctly said. Plastic has been such a useful commodity and we use it in everyday life, but now it's got its negative parts, and through our extended team, we have worked for the last 7 years to perfect a technology that we believe is a game changer. I'm here with Jacob.
Hello, nice to meet you, everyone. Yeah, my name is Jacob. I've been part of the team here for about 2 years. I mainly help out on the logistics side, but I also work very closely with the innovation team overseas. So I'd say I'm probably the most technical on our side in Australia. But no, I don't know, everything. I leave that to the PhDs and the innovation team over there. But I can definitely answer a lot of the questions. But yeah, excited to go through the presentation here, the questions at the end.
Yeah, so mostly what we're going to go through today is really the highlighted points to differentiate us from anything else really in the marketplace, and there's some key significant points of differentiation that maybe sets us apart from other technologies around the world of maybe similar type, but we'll go through that during the slide. Some of it might be repetitive as we try to hone in on a particular way of answering some questions. But yeah, let's start the presentation. All right, so we are 12-8 Technology. We started our company in Australia for the very purpose of finding the right solutions to eradicate the issues of plastic waste. And so we searched and found partners that we collaborate and work very closely with. We're in part of the inner core team, and we are thrilled that these people not only ethical, trustworthy, but they have the heart of the environment at the right place. You know, they really want to find a solution that is affordable and workable, and is not greenwashing, that does everything it says it's going to do. So yeah, it's an honor to be able to represent this technology. So we first look at some of the current problems to solve, and our little character that we had cartooned up, you know, is a rigid little plastic bottle, and that's purpose because we do take care of rigid plastic as opposed to more flexible plastic, but we can do flexible plastic as well. So we quite often comment as we are that like an eco insurance. We take care of that plastic that escapes recycling, circular economy, and ends up in the wrong place, whether it be in a landfill or in our environment. So we look at the current problem, which I'm sure most of you on this call would already be quite aware of. You know, the current solutions are all around to reduce, reuse, recycle, and we're thrilled that all around the world people are innovating new ways to take care of our waste. Here in Australia, we're reusing our waste in paving, in park benching, and all sorts of different substrates, and that's good. you know, it's good to recycle, and we should be doing the best we can to recycle and reuse and reduce and find a new life. But it is taking time. We need to change people's habits, and it is expensive. And to be honest, in Australia, only 9% is recycled. So, you know, the truth and reality is we can't keep up with recycling, but it's still important that we reduce and we find ways to recycle. There's papers and other types of cardboard, a lot more expensive than plastic, and it still affects the environment. It's limited in function, such as the toughness and heat resistance, to name a few. There's bioplastic, PLA, industrial degradable plastics, requires an industrial commercial compostable facility, up to 3 to 4 times more expensive than the original plastic, even more so nowadays. It's unstable supply, it's even going up, and a lot of the times are unable to get. It's a high cost of manufacturing, machinery, processing, and it's limited applications. We're also finding out that there's a lot of adulteration going on in PLA. We're not against PLA, it has its place, but we do know there's a lot of adulteration, meaning, you know, it's watered down and not really what it is, or says it is. And the fossil fuel-based degradable plastics, certain products degrade to microplastics and do not completely degrade. This is very harmful for our environment. We are very anti-microplastic and agree that anything that leaves microplastic and does not completely eradicate the plastic is not good for our environment. Certain products will not degrade in a low or zero oxygen conditions, such as found in aerobic and anaerobic waste deposits. And some have a limited application, such as film bags and thin plastics, and not so rigid. So that's a little bit of a high-level scope of some of the problems that we are looking to solve. So the vision of our business is to achieve maximum impact in reducing problematic plastic from contaminating and destroying our precious environment through advanced technology that tackles the issues in an affordable and effective way. And those two words are sort of bolded because we want it to be affordable, because if it's affordable, then it doesn't end up being a huge expense to the end buyer, the consumer. Yeah, we obviously will then be able to be used across many different sectors, and it's effective. Well, absolutely, it's got to work, and that is paramount in what we're doing. To transform plastic into a non-threatening, eco-sustainable product without compromising performance. Again, something that's important is the compromising performance. Pack2Earth provides technical advanced solutions for recyclable, naturally decomposing plastic packaging. And the words naturally decomposing also sets us apart. Where plastic becomes plastic no more, changing the landscape for future generations. So natural degradable eco-packaging technology perfected by packaging experts collaborating with nanotechnologists in advanced material science. This collaboration is an important part which I'll go into a little bit further. Pack2Earth positioning line is plastic to be plastic no more, and Pack2Earth is powered by Raws Tech. So the actual technology is called Raws Tech. And that stands for return to air, water, and soil. Make plastic accepted again. Yeah, it's had a pretty bad rap lately, and you know, we all have the advantages what plastic brings. So we want to aim to bring back the acceptance of plastic for the benefits that it does bring to our everyday life, the convenience. If plastic at the end of life is plastic no more, meaning no microplastic, no negative impact on the environment, plastic can still be an affordable solution for packaging when there is no other alternative available. And it's some market intelligence and research we've done in Australia, and when we've gone around and mentioned the word plastic, we immediately get a little bit of a frown. But then when we say, look, if we start life off as plastic, but really end up not as plastic, completely eradicated in natural conditions, would you then accept this certain usage for plastics? And the answer is normally 100% yes. The plastic to be plastic no more, how can we make that statement? We wanted it to be quite a simple statement for marketing purposes when we work with clients to have the Pack to Earth logo. And as you can see, the logo Pack to Earth in Australia or rest of the world, we say about returning back to Earth, or we've just changed the word back to pack. And then the K is a packaging, and it returns the arrow going back to Earth or Pack to Earth. Plastic to be plastic no more is what we are wanting everyone to know when they see our logo, that the plastic that has our logo on it will start life as a plastic, but will end up as plastic no more. So we begin life as plastic, same functionality, durability, characteristics, yet with one breakthrough advantage to any PP, PE, LDPE, HDPE plastic, with 1% of our RAWS tech added. At the end of life, it will return to air, water, and less than 1% harmless biomass. And the reason why there is a 1% harmless biomass is really the impurities in the original virgin plastic. You know, that's what's sort of left. In Australia, we're members of ABCO and ANSPAC, and we have quite a lot of certifications, which we can happily share further in our white paper or other documentations as we move forward. We've had FDA compliance, we follow the astm standards, and we've got European Food Safety Authority. What we offer for sale is, what we represent is a master batch, a film, or the end user. So we're quite diverse in what we can do. RAWS Tech master batch that can be incorporated into conventional PP or PE plastic, converting to natural decomposing plastics, or biodegradable pellets or sheet film can be easily used for injection of blister molders, or customized end user product solutions to brand owners to fit their sustainable needs and demands. So whatever a client is looking for, whether we're working with a manufacturer, plastic packaging company, or we're working with a client that wants the end user product, we can work on both. I talked previously about collaboration with the lab and the packaging professionals. This is a big difference to why we're so impressed and why we so enjoy working with our team, is that RAWS Tech was developed by top PhDs collaborating with experienced, over 20 years experience in packaging, the experts that make sure it's functional and works. So a lot of the time when there is a new technology, it may be developed in a laboratory, it looks good in theory and it maybe works and get results in the lab, but it isn't really functional. Is it really going to be working in a real life environment? And so everything that we provide and produce, whether it be the master batch or the end user, it's all been tested and perfected and tested and perfected. We prefer to err on caution and take our time to ensure that we've got everything known about the end user, what type of plastic we're working with, virgin or recycled, what the end result is that we're wanting to achieve, because we want to make sure that it's 100% effective. It is so important that our integrity of our brand is upheld, and that in no chance would we find that our claims will not be so. So working with the PhDs in advanced technology and nanotechnology and other aspects of material science, hand in hand working with very experienced packaging experts. The whole thought of this technology was really developed with that in mind, because it's as I said, with this collaboration and from a packaging person that wanted to see plastic eradicated and a functional, affordable solution. So certifications, I won't read all of that, but in terms of certification, even though NAMI is the laboratory that perfecting the technology, and the team at RAWS Tech is working alongside the laboratory, everything we do is tested third party to get the right certifications. This is again a very important part of what we do. because we want to make sure that we're not just saying, well, we're just not the ones testing it, we've got third-party evidence. So we have certifications in the ASTM 6954 Tier 1. Tier 2 is almost completed, and the results are like nothing we could have ever expected. They are getting down to a molecular weight of well under 2,000 and really proving that we have made significant advanced breakthrough. That's why we say it's a game changer. We've got the GPT standards, which is one of the hardest standards, if not the hardest standard to achieve in the biodegrading plastic market or certification, and we have achieved that, and that was something that we wanted to set out to do. I've got this slide in to talk a little bit about where it can be used. You know, so RawsTech is a blended, is an advanced pro degradant additive of 1% to the PP, PE, HTP, and LDP. It can be used for flexible packaging and rigid packaging, rigid plastic up to 10 millimeters, like milk bottles and caps and food containers are no problem for us. And I mentioned before that we take care of that escaped plastic that's not part of the current circular economy. There's a huge problem around the world, as we know, of small pieces of plastic that escape, or contaminated plastic that's got, you know, meat on it or something that's not going to be easily recycled. So we've got our own packaging value chain that we've put together, and basically, as I said, we want to be part of the circular economy, and I'll talk further about being recycled. However, in a real world, we've got to face the fact that, again, in Australia, 84% of all plastic will still end up in landfill, and that's a huge number, and that's landfill, never mind escape into the environment as well. So we really wanted to come up with a solution that takes care of that serious problem of ending up in landfill or left in the environment. So how does it work? Again, brief, we've got a lot more technical data available after this webinar, but our RawsTech enables the type of plastic to bioconvert within 2 years, leaving no microplastic, and it's toxic free in the environment. No commercial treaters needed. Globally recognized laboratories and international accredited testing facilities provide evidence of our claims. We've got activation. Our patented decomposing resin gets activated by natural light and or atmospheric thermal heat from the Earth's soil. That is one of our major breakthroughs that I'll talk a little bit further. First stage of breakdown, the process is where the resin breaks down to a polymer from 300,000 molecular weight down to 2,100. We're getting under 2,000. It's accelerating sometimes too fast in it, Jack. So we're having to, you know, in some ways slow it down in some particular types of plastic. We go down to what's called a ketone. Ketone is a watery slurry, and it's no longer scientifically a plastic. So that's why we can say plastic to be plastic no more. Naturally, it decomposes back to nature. The plastic will eventually be in a state where it can be digested by microorganisms and bacteria within 2 years. At this point, the plastic will degrade at a faster rate until it's fully degraded to air, water, and less than 1% of the harmless salt or biomass. And I've just got there a little bit of a RawsTech manufacturing process as well. And you can study that a little bit further when you get the PowerPoint. I've got this slide too. Again, I won't really read through all of this, but I just got it there to talk through how the ASTM 6954 Tier 1, Tier 2, and Tier 3 works, for those of you that maybe are not familiar with this international standard. And therefore thought this would be beneficial for you just to read as part of our white paper document that we've put together. And you can see that we passed Tier 1, and we definitely have no microplastic left. We've got third-party certification of that, and so everything is looking incredibly bright. Let's talk about no microplastic. It is a big issue that has stopped technologies in the past. mostly oxo type technologies, that oxo degradable, left microplastic, and there's reasons for that. But we have completely eradicated the issue of no microplastic. It's a rightful concern, but NAMI and the guys at Tech instructed a reputable independent lab, professional R&D service organisation, and a biopharmaceutical division of microspectrum technology to verify no microplastic, and we have all the certification evidence of that. The test was carried out using degradable PP sheet after going through the ASTM tier D6954 tier 1 test. So microplastic is a massive issue. We all know it. We are anti-microplastic, and we have third-party evidence that we do not have microplastic. We understand and recognize that other companies out there are claiming no microplastic as well for very thin film and very thin plastic. I think we're the only ones that I know of, and correct me if I'm wrong, but that has actually proven no microplastic in a much thicker, rigid plastic. Just a selection of some of our clients. As we said, we've been in the market in Asia. 7-Eleven work with us in their lunch boxes and plastic trays, meat trays, and all those type of sandwich packaging. KFC and Domino's and Deli France, Starbucks and IKEA. This is just some of the selection of clients. A lot of the largest supermarkets also in the Hong Kong region. And we are also talking to way over 100 clients at the moment around the world, and some of the biggest recognized brands as well, who are in testing with us and very pleased with the results, incredibly pleased. But as I mentioned before, we want to ensure that we perfect the technology to make sure it's right for the right environment, the right conditions, and the right for the client, and making sure that's going to work. So we take that time to work with these large clients to get it right. I mentioned about one of the major breakthroughs, and this is one of those major breakthroughs, the thermal bio side. From what we understand, to our knowledge as of this date, there is no one other than us that can work in our type technology without UV light. Every other company needs the UV light to get the plastic to decompose. I don't like using the word breakdown, but to break down. But we do not need UV light. So Pack2Earth Tech is a new generation of environmental plastic master batch, heat degradation plastic master batch, a thermal biodegradable plastic which complies with the international degradation standard and with the US patent pending. We've got all the US numbers, and the US patent being pended, lodged a couple of years ago, will make a strong contribution to the global reduction of environmental pollution caused by disposable plastic products that remain intact for generation. Part of this too is oxygen has been inbuilt into the ingredient to be released when the process starts, which means that it does not need to be exposed to sunlight or the atmosphere. As long as the ground temperature is above 16 degrees, which when buried it is, to which tests have been done, but not certified. So we're certified to 25 degrees. Yeah, but we haven't, that we've certified 25. That's why we got the China standards, but 16 degrees is what we're getting in the lab, which is the minimum soil temperature in most countries, and much higher in compost and landfill. Then it will release the ingredient and start to oxidize and break down the plastic, whether it is a coffee cup, plastic cup, plate, cutlery, meat tray, whatever, they will break down in the same way. So really that's a major point. There's a large company in, well, a brand in UK, government backed and backed by a lot of wealthy investors that are also, I think, working in the Indian market, but they claim there's nothing that can break down in landfill because of the lack of UV light when it is buried, but we have solved that issue. Affordable, and the process and the speed. Pack2Earth Tech products are affordable. This was important. Obviously, we can't come up with an exact percentage because it can differ depending on how much plastic is in our end user. Some of the plastics that clients we're working with have up to 9 layers of different plastics to get to what type of packaging they currently use. But we say between 5 and 20% is definitely no more than 20% in terms of the added cost to using and working with us. It definitely will be not 20%, but you know, we work to obviously make it as affordable as possible. It does not interrupt the traditional manufacturing process like other maybe bioplastic PLA. It does change the manufacturing processes and can be costly and fiddly. We do not change the manufacturing process. With experienced processing skills and modern equipment, it will not slow down the manufacturing time. That was a question we were recently asked, a very good question, because you know, the speed is important. So you know, we do not believe we will slow down the speed once plastic has our additive in it. Injection molding vacuumed correctly, there's no difference. Blow molding due to sheet and set form with a skillful operator will have no difference. And now the bottom here, I've just got, you know, plastic plant pots is something that we're looking at as our solution can work with that type of plastic. No toxicity, organic and FDA compliant. So Pack2Earth RorsTech is FDA compliant and it's organic in its making. Therefore, it's got no toxins in it. It has no risk or toxicity and has passed the FDA and EU food requirements for plastic safety. It will not leach into the plastic. It will not leave any toxic residue in food contents of the container it is used in, or, you know, from all we've tested so far, whether, you know, whatever is in a bottle, it will not leach at all and change the perfume or the food, because it will not leach. Again, I looked down the bottom there, the lolly sticks, or the little plastic stick there, you know, there's so many of those things that people wouldn't think to maybe recycle, but if it had our technology, then, you know, we can take care of that in landfill. No commercial or industrial treatment. Since I got involved in this technology, and even though I've had advertising agencies for 20 years and worked in packaging, I've never sort of, I guess, seen something that's misled people in that I myself thought when I received a cup or piece of plastic that had, you know, commercially biodegradable, commercially compostable, industrially compostable, I immediately thought that means that, you know, it will break down. Now I'm wiser and I know that it all needs a industrial treatment, treatment up to 60 degrees, 140 degrees Fahrenheit, continue for 2 days to break down, followed by a lengthy process. Pack2Earth RorsTech requires no special treatment. Instead, it will naturally degrade with either UV light or thermal heat with 0 to limited oxygen. As I said, to say commercially compostable to us is a bit misleading, and you know, a lot of these companies are very clever in their marketing, the way that they spin the story. That doesn't really tell the full truth. Virgin or recycled plastic, either or. Pack2Earth RorsTech can be made with either virgin or recycled plastic. Once the RorsTech additive has been added, the original plastic is set to be plastic no more once the predetermined trigger date has expired and natural decomposing has begun. So imagine recycled plastic packaging that will naturally decompose to be plastic no more, a win for the environment. So we're talking to some big companies at the moment that may be happily making a claim that their plastic is 20 to 30% or 40% recycled plastic. But when our additive is also added to that recycled plastic, then we can make sure that it's taken care of if it ends up in the wrong place. Recycling. We get asked this a lot. We know that plastic with RorsTech can be recycled. Our manufacturing team, companies and partners that we're working with, when they're making the plastic, there's normally quite a lot of wasted material that's all collected and recycled. So it can be recycled. So the packed to earth raw tech can be recycled just like any other traditional PP or other recyclable plastic. It can be mixed with other plastics in the recycling process. During the recycling process, especially if it's mixed with other plastic, the raw tech additive is diluted and reduces to the point where it's not effective anymore. So obviously the next evolution is not going to have our technology working or active because it's nullified by the extreme heat generated in the recycling process. As it melts, the plastic will destroy the active additive, stopping it from the decomposing process. So this is something that we're continuing to explore and work more with other recycling companies to find out how much our raw tech plastic or packed to earth plastic would affect when it's recycled, and as long as that it has not reached its trigger date, then it can be recycled. Obviously, our technology is made in such a way that it's to take care of plastic that escapes recycling, escapes the circular economy. So that was what was an objective from the beginning. However, if it starts to decompose, it's sort of already in that decomposing state, then we recommend not to obviously be recycled. That would not be right. But definitely beforehand, it's okay. So rigid or flexible. I mentioned this before. Packed to earth raw tech can be used in any PP or PE plastic, from flexible plastics such as cling wrap, shrink wrap, or rigid plastics such as food containers and or retail product packaging. The advanced technology provides a solution for contaminated problematic plastic, with all tests carried out by local government-backed enterprises using rigid plastic, not the thinnest plastic as a test. Maybe Jag, you want to talk about the tests on the rigid plastic that they've been using rather than thin?
Yeah, so the team with NAMI, they really set out to be a solution for all types of plastic, and they really wanted to tackle the issue of the rigid packaging, because there are many solutions out there that can tackle the thin films and all the cling wraps and all that kind of thing, but there's nothing else out there that can tackle the rigid. So all the testing that has been carried out, has minimum specifications of samples they have to provide. And the team have gone well above those minimums just to prove that we can handle the rigid. So all our tests are done on 5 mils or 0.5 centimeter, which is well thicker than any rigid plastic product that you'd see in the market. So we really do have a solution for those those hard plastic, rigid plastic items that there isn't any other solution for.
Frozen and or high heat packaging. These products on the right are just for illustration only, but they're good illustrations in that it sets apart some of our differentiation as well from maybe the PLA. Tech organic additive is perfect for frozen food applications to plastic requiring high heat, from -25 degrees to 100 degrees, with no impact on the plastic to be plastic no more at the end of life. It will, however, be nullified in the higher temperatures used in recycling process of over 169 degrees. So when you've got someone like maybe a McCain Foods that uses plastic for frozen chips, fries, very sharp when frozen, they maybe have many layers in their plastic. Because it's frozen to -25 degrees, it will not affect our technology at all. Then we get another example here where you might have in Australia, we've got these sausage rolls or meat pies in Australia, where you've got the plastic wrap around the outside and it's frozen, and then it's microwaved, and then it's put in a heater or warmer. Again, we can work with this as a solution because we don't get affected at all. So very, very versatile in both spectrum, from frozen to heat. We've been microwave tested as well, so that's passed all the microwave tests. We've got independent microwave testing on any plastic with the raw tech inside. And in terms of strength, we don't affect the original durability, functionality, strength of the plastic at all. we do not change the characteristics of the original plastic. Time-controlled shelf life. This is a great advantage, but it also inhibits us in some ways getting some of these compostable standards, which I'll go through in another slide. But a time-controlled shelf life is something that all the brands we've been talking to and businesses want. They want it to be shelf stable. They want time so they can store packaging in the right environment, and it's not going to start to be brittle or break down or decompose. So we put in a time-controlled shelf life. In the Pack to Earth Tech products, have a store date built into the formulation, bringing stability and holding back the natural decomposing process from 6 months to up to 4 years. We can't really go past 4 years, but and still claim that it's not going to start to naturally decompose, but yep, up to 4 years. So a company that may want to store packaging for 2 years and then 1 year on shelf, you know, they really don't want it in any way decomposing. And yet other usages maybe want it as fast as possible to come in and do their thing and then go. So this allows for the transportation, product storage, and predetermined shelf life of the product. In theory, naturally compostable. So what I mean in theory, I said we never want to be a company to make any claim or statement that we can't back up. So at the moment, you know, a lot of around the world, they want the industrial or home compostable standards. In Australia, they want that. But by nature, we are compostable, because when we're in a landfill, buried, we will decompose within 2 years back to air, water, and 1% biomass. So Pack to Earth Tech products will naturally decompose within 2 years once the predetermined store is triggered and that date is expired. For this reason, it will decompose in natural compost, just like in a landfill. However, due to the short-term requirements for compostable standards in Australia, and I'm sure in other parts of the world, our built-in store stops the plastic from reaching a certain stage within the 90 days. So we're not going to start really seeing much change, you know, in that first 6 months. And then we start to see the decomposing. If we have set the store for 6 months, then we're going to start to decompose. And again, we can show you some of these charts or graphs in terms of our rate of decomposing, because it accelerates, and then at, you know, at the very end, when it's already not a plastic, you know, it takes a little bit longer for the microorganisms to completely take it away. We are recommending that all our products are best for recycling and landfill, but should they end up in natural compost, then they will decompose just over a longer period. So again, we're not making a claim to any of these compostable standards that certain countries like the one we live in require, but we are actually saying in theory, by our very nature of the way that we decompose in a natural environment, in the landfill, that we can be compostable. Manufacturing facilities, I mentioned at the very start, you know, we have the partnership with NAMI, but also the state-of-the-art manufacturing facilities, and we're expanding and growing because of the needs and the inquiries that are coming through at the moment are incredible, and it's pleasing to see. So we have a very large manufacturing facility and capacity. So a lot of people are asking, are we in the market? So we are definitely commercially in the market. As I said, we've got clients already working with us. We've had no issues, no problems whatsoever. So that's gives peace of mind to clients looking to partner with us. Going on the next step after this call or this webinar, the way we like to work, and working closely with Sandeep and the Packaging Connection team, is to look at a scoping call with our innovation production team to better understand. You know, we will send out scoping documents and inquiry forms to be filled out, because we really want to understand the specific needs and wants and requirements. Once understood, we can formulate and make any necessary refinements to perfect and customize Pack2Earth Raws Tech to ensure the product performance. We recommend going into a collaboration to ensure that the integrity is upheld. This is also, again, something that we hold very tightly, in that we always want to be in collaboration to make sure that it works. So for the sake of our brand and for whatever client we're working with, we must ensure that what we say will take place. And so therefore we err on caution to make sure that we get everything right and understand everything. And sometimes it takes a bit longer, but I said we get there. Other times when it's something that we're already in mass production, like cutlery and cups and bowls and all those sort of things, obviously we can speed up because we already know that that's working. So once we've tailored made the master batch film or end user products, we're able then to provide more accurate pricing and then timelines. Again, we only use 1% master batch no matter what. It's only ever 1%. Because we will tweak or refine the 1% master batch depending on the thickness of plastic, the usage of the plastic, and the time frame of the decomposing, etc., etc. So we definitely want to get into a relationship with our clients for the long term, and we're not here just to quickly sell something off the shelf and say, here you go, quick, this is a quick fix. We want to be able to go the journey to get it right, and I think all of you on the call would respect that. So that's the end of the overview of what we have. As I said, I think from here we can now receive some questions, and this is where Jake can talk a little bit more and save my voice. If they're really technical, then we would ask you to maybe put it in writing to us, and we will find the answers for you. We've had a lot of clients ask technical questions before, so a lot of the Q&As we already have, and then can provide from what other people have asked in the past or around the world. So that's available. Yes, I said before, we can step further into providing white papers and certain certification that we've already had, or test results as well. So that's it. Back to you, Sandeep.
Thank you, Anthony. Thank you, Jacob, for this wonderful talk through taking to the technology and the topic, which is very, very important in today and close to my heart. And so I just would like to tell that everybody, the recordings of this webinar will be available to you, and we will send you the link and the copy of the presentation later on. We have your details, and as Anthony mentioned, we can go through much more detailed technologically one-to-one once we do the scoping, and our team will be in contact with you. In the meantime, if you have any questions, so what I will do, I will now unmute you, so that if you want to ask any questions, you can unmute yourself and ask. Yes, so all of you have been unmuted from the technical point of view. So if you would like to ask the question, you can unmute yourself and ask the question. And or maybe you can type the question. Yeah, go ahead.
Hello, Usmani is this side from Polyplex. My question is that, is there any master batch for the polyester films?
For polyester, we do not have right now. We have it for polyethylene, olefin groups, which is LDP, SDP, and PP. For the polyester, we are still working on it. Anthony, is that right?
Yeah, that's correct. They are working on other variants on PET and for polystyrene as well. They're also working on a blown PP and PE, which has similar properties to a polystyrene, which will probably be in production end of this year, which we might be able to share a bit into as well if someone's interested in that as well. But at the moment, the ready-to-go product is just for PP, PE, HDPE, LDPE.
Thanks for your confirmation.
Yeah, no worries.
So I think there's another question. If it says the activation period begins from the manufacture date of the pallet or from the first extrusion with the PP?
From extrusion, from the time controlled shelf life will begin at extrusion. And that shelf life, as we mentioned, we can tailor make that to 6 months all the way up to 4 years to counter in any, production time or companies that have, plastic packaging in warehouses for a few months. We can factor that all in and get them at the right shelf life to match the product.
Okay, and another is, how is the activation date programmed?
So that is engineered by NAMI. So we will work with any client that is interested in working with us. So we will get all the specifications. We'll send samples to the NAMI laboratory, and they will test the product, and they will customize the master batch and engineer the shelf life into the master batch. So you don't need to worry about shelf life or changing addition rates. It's always 1%, and then we will obviously show all the evidence and proof that the product will break down after that shelf life. We can supply. We have all access to accelerated weathering tests and all those kind of facilities to prove that it does do what it says it's going to do.
Okay, and then does it also work for the thermoforming sheets? If PP?
Yes. Yep, thermoforming. Yeah, we have a client in Australia that is a seafood manufacturer looking at us now, and they thermoform meat trays at the moment. So yeah, seafood trays.
Okay, and then another question coming, does it degrade on the sea?
So for the sea, we have done early testing in-house on that, and the short answer is yes, it does. We have a client who manufactures straws in Hong Kong, and he put some straws with our additive into a big thing of water and left it outside, and it clearly was breaking down. In the ocean there is the heat that is naturally in the water, and that's all that product does need to start the breakdown. We aren't certified for marine yet, but that is something we are looking into to get that box and get it ticked off. But in theory, yes, and we have proven it as well, but we just haven't got the certification as of yet.
Definitely in the process to get that certification though, because we know it works.
Okay, then there is another question. I think you answered it also before, but does it have FDA and other food contact approvals?
Yes, so we're FDA certified, and we also have the European equivalent.
And the Asia equivalent.
Yeah, and the Asia equivalent for food contact.
We're already working with 7-Eleven with food contact, so we're in, all of their stores.
Okay, so now if no more questions, I think then I would like to thank you audiences and our team, 12-8 team, Jacob and Anthony from Australia, and the team behind making it possible. Thank you and have a good day. Bye. Thank you.
Thank you very much.
Thank you everyone, and thank you Sandeep. Decomposing, how do you say that?